Hi everyone, this is Arvind from MindMajix, and today I welcome you all to this amazing video on microservices interview questions. So guys, in this particular video, we will be covering roughly around 30 questions, and all those 30 questions are divided into three categories. So like the first 10 questions will be the freshers or the beginner level questions. The second category will be for the intermediate folks or like those people who have at least a couple of years of experience with microservices. And then we have the advanced category, like the last 10 questions. And in those 10 questions, like we will be covering advanced concepts. Like it will be specifically for those people who have at least 4 to 5 years of experience with microservices. Okay, I hope the agenda is pretty much clear and easy to understand. And before moving ahead, I want you guys to subscribe to MindMagic's YouTube channel and also hit that bell icon so that you never miss an update from us. So without any further ado, let's get started with our first question. So the first question over here is like obviously a very basic question. What are microservices? So in this particular question, you have to just explain the definition of microservices. So like microservices are an architectural style wherein an application is built as a collection of small, independent, and loosely coupled services. So each service in this microservice is designed to handle a specific business capability with its own logic and database. And this was a quick definition of microservices. And over here, you can also give an example. Like, let's suppose in an e commerce platform, the product catalog, user management, and order processing and payment services are designed. Like, all of these components are like all of these modules are designed separately, and each one of them is a separate microservice. So, what is the advantage of building these modules as separate entities? So, this enables each service to be developed, deployed, and scaled independently. So, this was an example of microservice. The next very important question over here is, how do microservices differ from monolithic architecture? Like before microservices, we had the monolithic architecture. So over here, you have to just explain the difference. And in this particular question, we will be comparing microservices and monolithic architecture based on some parameters. So those parameters are, as you can see on the screen, architecture, scalability, technology stack, deployment, and use case. So let's discuss these points one by one. So if you talk about architecture, so for monolithic architecture, you have a single code base that contains all of the modules tightly coupled into one executable. Whereas if you talk about microservices, so here they are basically decoupled, like all of the modules are separate entities and they provide modular services, and each one of them is designed for a specific business function, and the communication happens through APIs. Now, if you talk about scalability, so for monolithic architecture, it primarily relies on vertical scaling, like adding more resources like the CPU or memory to a single server. Whereas if you talk about the scalability for microservices, so here the focus is on horizontal scaling, like adding more instances of individual services as and when required. If you talk about the third point, which is the technology stack, so basically for a monolithic architecture, it requires a uniform stack for the entire application, limiting the flexibility. So the flexibility aspect is very limited for a monolithic architecture. Whereas if you talk about microservices, so this allows a diverse stack, and this lets team choose the best technology for each services. Then the fourth point over here is deployment. So for monolithic architecture, everything is deployed as a single unit, requiring the entire application to be redeployed for changes. So if at all you have to make any changes in the monolithic architecture, so you have to again redeploy, like you have to make the changes first and then redeploy the entire application. Whereas if you talk about deployment for a microservices architecture, so here you can independently deploy a particular microservice. So what is the benefit over here? So this allows updates for one services without redeploying the others. So only that particular microservice where you need update, that you have to redeploy. You do not have to redeploy the all of the microservices. And the last point over here is the use case. So for a monolithic architecture, it is very much suitable for smaller applications or system with fewer updates and minimal scaling needs. Whereas if you talk about microservices, so here it is very much suitable for large, complex and rapidly evolving systems requiring scalability and flexibility. So I hope this clears the difference between microservices and monolithic architecture. The next question over here is, what are the key features of microservices? So guys, there are basically three important features of microservices, as you can see on the screen. The first one is independent deployment. So basically in microservice, each service operates independently, and this allows for seamless deployment, updates, and maintenance without impacting the functionality of other services. And now, if you talk about fault isolation, so basically, a failure in one service does not cause the entire application to fail. So, this ensures a greater resilience and minimizes the downtime. For example, if Netflix's payment gateway service experiences some problem or glitches, so it does not disrupt the streaming service as they are isolated or like they are the separate components. And the third point over here is the scalability. So each service can be scaled independently based on its specific load and demand, and thereby optimizing the resource usage and improving the performance. For example, during peak time, Netflix can scale its streaming service while keeping other services like account management at baseline levels. So these features collectively make microservices highly adaptable, resilient, and efficient for modern applications, especially for those requiring dynamic scalability and high availability. The next question over here is, name the main components of microservices. So, guys, in this particular question, you have to mention in detail the components and the characteristics of microservices architecture. So, first, if you talk about the characteristics, so over here, as you can see on the screen, these are the important characteristics or some important principles on which entire microservices concept has been derived. So if you talk about core characteristics, so here you have service independence, domain driven design or the DDD, then you have the API communication, and then you have the technology diversity. And if you talk about the main components, so basically, as you can see on the screen, these are the important components of microservices architecture. Let's just describe them one by one. So if you talk about service registry and discovery, so basically this is a centralized system that helps the services locate each other dynamically. For example, Netflix Eureka, Console, or Kubernetes. Then if you talk about API gateway, so this acts as a single entry point for clients, routing requests to appropriate services and handling concerns like authentication, logging, and rate limiting. Then the next important concept or the component over here is the load balancer. So load balancer basically distributes the incoming traffic across the instances of a service to ensure high availability. Then you have the data management. So basically each service typically manages its own database, like database per service pattern, and this ensures the loose coupling among different services. Then you also have the monitor and logging. Over here, you have tools like Prometheus, Grafana, and ELK Stack, and these tools ensure real time monitoring and debugging. And last but not the least, you have the CI/CD pipeline. So basically, CI/CD pipeline automates testing, deployment, and scaling, and it ensures faster iterations and minimized downtime. So these were some of the important components of microservices architecture. The next question is, explain the role of API gateway in microservices. So guys, just in the previous question, we have seen that API gateway is one of the crucial, or you can say a very important component of microservices architecture. So in this particular question, you have to explain in detail what is an API gateway or what is the role of API gateway in microservices. So an API gateway serves as a centralized entry point for managing client interactions with microservices. Basically, it simplifies communication by routing the incoming requests to appropriate microservices and handles the various operational responsibilities as well. So if you talk about the responsibilities of an API gateway, so there are three primary responsibilities of API gateway. The first one is request routing. So the API gateway directs incoming client requests to the microservices based on the operation that is being performed. The second responsibility is load balancing. So basically, an API gateway distributes requests evenly across the multiple instances of a service to ensure optimal resource usage and high availability. And the third point over here is authentication and authorization. So the gateway verifies user credentials and enforces security policies to ensure that only authorized users can access specific services. So let's consider an example over here. So if you have a travel app, so over here the API gateway acts as a mediator between the clients and the services. So whenever a user interacts with the app, so what is the role of an API gateway over here? So with the help of API gateway, routes booking related requests to the booking services. So basically you have a request from a user for booking a particular travel mode, like maybe it can be a flight or a train or a bus. So those requests are directed or diverted to the booking services. So apart from that, you can also have users who want to do the payments for a particular service that they're using. Like for example, they have booked a ticket, so they want to now do the payment. So an API gateway will direct this kind of request to the payment operations or the payment gateway service. And then after this, you can have itinerary queries, like user can request or they want some information regarding the itinerary of a destination. So these kind of queries are directed to the itinerary manager service. So by centralizing these operations, the API gateway streamlines the client experience while ensuring efficient and secure communication with the microservices. So the next question over here is, what is service discovery in microservices? So service discovery is basically a mechanism that enables microservices to dynamically locate and communicate with each other within a distributed system. So now what is the advantage or benefit of service discovery in microservices? So basically it ensures that the services can find and connect to other services without hard-coded configurations, thereby promoting flexibility and scalability. So guys, there are basically two types of service discoveries in microservices. The first one is the client-side discovery. So in this particular approach, each service is responsible for keeping track of and managing its own service registry. So the client queries the registry to locate the available service instances and then chooses the one to interact with. And the second type is the server-side discovery. So, centralized registry such as the Eureka or a console maintains the locations and the statuses of all services. So, when a client makes a request, the server side load balancer queries the registry and routes the request to an appropriate service instance. So, this was all about service discovery in microservices. The next question is, what is a container and why is it used in microservices? So basically, a container is a lightweight, standalone unit that bundles an application along with its dependencies, including libraries, configurations, and runtime to ensure consistency across different environments. So this was a simple and a light and a crisp definition of a container. Now, why do you use container in microservices? So basically, there are two important benefits of using containers in microservices. So the first benefit is the consistent deployment. So containers ensure that the application run the same way in development, testing, and production environment, and this minimizes the compatibility issues. And the second advantage is faster startup time. So containers are more lightweight and have faster initialization times compared to traditional virtual machines, thereby enabling quicker deployments and scalability. So for example, by using Docker, A payment microservice can be packaged with all of its dependencies to guarantee that it performs identically on a developer's machine, a test server, or a production server, providing reliability and efficiency throughout the development lifecycle. The next question is, how do microservices communicate with each other? So in a microservices architecture, the communication between service is very important for achieving the coordination and collaboration. So since microservices are designed to be independent and loosely coupled, they rely on well-defined communication protocols and mechanisms. If you talk about the methods of communication that is used in microservices, so the first technique is the RESTful APIs. So RESTful APIs means, like if you talk about the REST, so REST basically means representational state transfer. So this is a lightweight and a widely used communication protocol, and it uses HTTP methods like get, post, put, delete to facilitate synchronous communication between services. The second technique is through message queues. So message queues enables asynchronous communication between services, thereby allowing messages to be sent and received without requiring the services to be active simultaneously. So now if you talk about the popular tools over here is, so here you have Apache Kafka, AWS SQS, and RabbitMQ. And the third technique by which microservices communicate with each other is the gRPC, or the G remote procedure call. So basically this is a high performance framework developed by Google. So it uses HTTP2 for communication and the protocol buffers for data serialization, and thereby this makes it more efficient than the rest for some use cases. So these are the three techniques through which microservices communicate with each other. The next question is, how would you handle a microservices failure? So basically, in a microservice architecture, failures are inevitable. But the goal over here is to minimize their impact on the overall system. So since microservices often communicate with each other, one failure can trigger a chain of reactions, thereby leading to cascading failures that affects the entire application. So to mitigate such issues, there are several techniques and the best practices for handling the microservices. So the first technique over here is the circuit breakers. So a circuit breaker is basically a design pattern that helps prevent cascading failures by stopping the flow of requests to a service that is likely to fail. So if a microservice detects that another service is not responding or is behaving in a weird way, so the circuit breaker opens, preventing further requests to the failing service, and this allows it for the time to recover. The second technique is retries and fallbacks. So when a service fails to respond, a retry mechanism can automatically attempt to resend the request after a short delay. So this is particularly useful in scenarios where the failure is due to temporary issues such as network congestion or brief outages. And the third technique is centralized logging. So in a microservices environment, troubleshooting and identifying the root cause of failures can be difficult due to distributed nature of the system. So over here, centralized logging aggregates the logs from all of the services into one location, and this makes it easier to monitor the system and quickly identify and resolve failures. The next question is, how can you ensure backward compatibility in microservices? So backward compatibility is very important when deploying the updates to microservices to avoid breaking the client applications. So using the versioning in APIs and following a semantic versioning principles can ensure the smooth transition. So just to give you an example, Microsoft maintains backward compatibility in its Azure services by following strict API versioning practices, providing a smooth experience for developers and the applications. With this, we have covered the beginner level questions, or the questions that were meant for the freshers. And now question number 11 onwards, like 11 to 20, we will be covering the questions that are meant for the intermediate folks, or the intermediate people who have at least 2 to 3 years of experience with microservices. So the next question over here is, what is the meaning of OAuth and why it is used? So basically, OAuth stands for Open Authorization. So it is an open standard protocol that allows third-party applications to access a user's resources without exposing their credentials, such as usernames or passwords. So OAuth provides a secure and a user-friendly way to grant access to certain parts of an application or a service without directly sharing the sensitive information. The next question is, what is CQRS pattern in microservices and what problem does it solve? So basically, CQRS stands for command and query system, in which data operations are separated into two commands, which writes data into the database, and query system, which reads the data from your database or a data storage. So by splitting your application into two components, you can better optimize your applications depending upon whether it is a write heavy or a read heavy application. The next question is, compare API gateway and load balancer in microservices. Like basically, you have to explain the difference between an API gateway and a load balancer in microservices. So load balancer is basically an old concept which is used to distribute load or traffic across multiple instances. So it can be implemented as a hardware solution or as a software solution, but distributing load is its main function, and it can be just used on microservices, but it can also be used on monolithic and service oriented architecture. On the other hand, if you talk about the API gateway, so this is a microservices pattern which not only does load balancing, but it can also be used for lookup, and it can also simplify the client code. So instead of remembering hundreds and thousands of microservices, client can only remember API gateway host and the port details. So you can also implement authentication, authorization, security, and other cross-cutting concern at API gateway level instead of implementing them on each microservice. So basically, in short, API gateway does a lot more than a load balancer. The next question is, what are some common microservices design principles? Microservices architecture provides a more scalable and a flexible approach to develop a distributed application compared to traditional monolithic architecture. And now, if you talk about some design principles of a microservices architecture, so these are the various principles that need to be kept in mind before designing a microservices architecture or an application. So the first principle over here is high cohesion. So high cohesion basically refers to the design of each microservices to be focused around a single well-defined responsibility or a business capability. A cohesive service should be limited for a specific task or a set of related tasks with minimal dependencies on other services. The next design principle is being autonomous. So microservice should be designed to be autonomous. So what does it mean? So it means they should operate independently without depending on one another. So each microservice should have its own data, business logic, and the interface. So this principle emphasizes loose coupling between services so that one service failure does not affect the other services. The next principle over here is business domain centric. So microservices should be aligned with business domains or capabilities rather than technical layers or function. So each service should correspond to a specific business function or a capability, making the architecture more intuitive and closely tied to business objective. Then the fourth principle is that of a resilience. So basically, microservices should be resilient to failure and designed to gracefully handle disruptions or faults. So this includes strategies like redundancy, circuit breakers, retries, and fallbacks to ensure that a failure in one service does not lead to a system-wide downtime. Then the fifth principle over here is being observable. So observability basically refers to ability to monitor and track the health and performance of microservices in real time. So this includes logging, metrics, and tracing to capture the insights into how services are performing and interacting with one another. And last but not the least, you have the automation. So, automation is a key principle in microservices design, and this refers to the use of automated processes for deployment, testing, scaling, and management of microservices. So, automated pipelines can ensure that microservices can be deployed quickly and reliably. The next question is, how do you ensure security in microservices? So, securing microservices is a crucial thing, and it is very important as you need to protect the sensitive data and maintain the integrity of interaction between the services. So, since microservices typically involve numerous services communicating with one another across different environments, so they are more vulnerable to various security risks compared to traditional monolithic architecture. So, now if you want to ensure security in microservices, so there are a few practices that you need to follow. The first practice is secure the communication. So, securing communication refers to encrypting the data exchange between microservices to prevent eavesdropping, man in the middle attacks, and unauthorized data access. So, this is done by using the TLS or the transport layer security or the SSL, which is the secure socket layer protocols. Then, the second practice is authentication and authorization. So, authentication and authorization ensure that only verified and authorized users or services can access specific resources in the microservices system. So, authentication verifies the identity of the users or services, while authorization defines what actions or resources they can access. And the third practice is service level isolation. So basically, this refers to restricting access between microservices to only the necessary communication paths. So this ensures that the services interact only with the ones that they are meant to communicate with, reducing the risk of an attacker gaining access to other services. The next question is, what are the few ways to achieve synchronous and asynchronous communication between microservices? So there are many ways to implement synchronous communication in microservices architecture. Like over here, you can use the RESTful API calls, gRPC, or the GraphQL API to retrieve the data from server in synchronous manner and also to upload the data to the server. And now if you talk about the asynchronous communication, so over here you can use tools such as Apache Kafka, RabbitMQ, and ActiveMQ. So here message brokers allows senders to send and forget, and receiver then can process when they are free, giving both the sender and the receiver the freedom to work based on their speed. The next question is, how do you implement rate limiting in microservices? So rate limiting is a very important aspect of managing the load on a system, especially in microservices architecture, where multiple services interact and can experience heavy or unexpected traffic. So rate limiting ensures a fair usage of resources by controlling how many requests a client can make within a certain time period. So this protects services from being overwhelmed by too many requests, preventing abuse, and helps to maintain the system's stability and performance. So basically, there are two techniques or two ways to implement rate limiting in microservices. So the first technique is by the use of token bucket algorithm. So basically, the token bucket algorithm is a widely used technique for implementing rate limiting. In this particular method, tokens are replaced in a bucket and each incoming request consumes one token. So if the bucket has tokens available, the request can be processed or like it can be proceeded further. If not, the request is denied or queued. So the tokens are refilled periodically at a constant rate, thereby allowing the client to make new requests over time. And the second technique over here is the API gateway for rate limiting. So an API gateway is a critical tool in microservices that serves as the entry point for all client requests. So basically, it can be configured to handle the rate limiting for all incoming traffic before it reaches the backend services. The next question is, what is an event-driven architecture in microservices? So event-driven architecture is a design pattern where microservices communicate with each other by producing and consuming events rather than making direct API calls. So in this architecture, services emit events to signal that something has occurred, and other services listen to these events to trigger actions or processes in response. So this pattern enables asynchronous communication, allowing services to operate independently without needing to be tightly coupled. So basically, event-driven architecture helps increase scalability, flexibility, and responsiveness in a microservices ecosystem. So just to give you an example of an event-driven architecture, so Netflix is based on this particular architecture. So basically, the Netflix platform consists of numerous microservices, and the interaction between these services are, are powered by events. For example, when a user starts streaming a movie, the video service emits a user started watching event. After this, the recommendation service listens to this event and adjusts the recommendations for the user in real time. And based on that, the billing service might consume an event indicating that a user has watched a certain number of movies and might consider adjusting their subscription plan. So, by using the event driven communication, Netflix decouples services, enabling them to scale and evolve independently while maintaining seamless user experience. The next question is, what is idempotency and why it is important in microservices? So idempotency is a key concept in a distributed systems and microservices architecture. So this ensures that making the same request multiple times produces the same result regardless of how many times it is executed. So this characteristic is crucial for systems that need to handle retries due to transient failures, network issues, or other interruptions. So in microservices where communication is often done over unreliable networks, it is common for requests to be retried either by the client or the system itself. So without idempotency, retrying the same request could lead to inconsistent or undesirable outcomes such as creating duplicate records or performing the same operation multiple times. So idempotency basically helps to eliminate these issues by guaranteeing that the repeating a request will not alter the final state of the system. The next question is, what is database sharding and why it is used in microservices? So basically, database sharding is a technique that is used in distributed database system where a large data sets are divided into smaller, more manageable pieces called as shards. So each shard contains a subset of the data and can be stored on separate database instances or servers. So in microservices architecture, database sharding is particularly useful as it allows each service to handle its own database, ensuring that no single database becomes a bottleneck as the system grows. So each microservice can operate independently with its own shard, which can be scaled as and when needed without affecting the other services. So, guys, with this, we have covered the questions that were meant for the intermediate candidates. And now, question number 21 to 30, we will be covering the advanced questions. So, the next question over here is, how do you handle data consistency in microservices? So, in a distributed system, maintaining the consistency across different services is pretty much challenging. So microservices typically follow the eventual consistency model where all the services eventually converge into the same data state rather than maintaining the immediate consistency. So there are a few techniques to handle the data consistency in microservices, and those techniques are, as you can see on the screen, saga pattern, event sourcing, and distributed transactions. So if you talk about saga patterns, so there are two important points over here. The first one is choreography. So over here, the services communicate through events, and each service performs its task and emits an event for the next service. And the second point over here is the orchestration. So basically, a central coordinator manages the workflow between the services. Then the second technique is by using event sourcing. So events rather than the final state are stored in microservices, and the current state is derived by replaying the events. For example, a payment service stores the events like payment initiated and payment completed, and these events are often replayed or reconstructed as per the status of the payment. And the third technique is distributed transactions. So over here, you use two-phase commit or 2PC or compensating transactions for critical operations. For example, while booking a hotel or a flight simultaneously requires both operations to succeed or roll back entirely. The next question is, what is a canary deployment in microservices? So a canary deployment is a software release strategy where a new version of a service is gradually introduced to a small subset of users before a full rollout to the entire user base is done. So basically, this approach aims to minimize the risks associated with deploying new code by allowing for controlled testing and observation in a live environment. The next question is, how would you monitor the microservices? So basically, monitoring is a crucial aspect for ensuring the health, performance, and overall stability in a microservices where everything is in a distributed system. So it provides valuable insights to the behavior of individual services and their interactions. So basically, there are a few steps through which you can monitor the microservices. So the first step over here is distributed tracing. So now using distributed tracing, you can track the flow of requests across multiple services in a distributed system. So this helps identify performance bottlenecks, pinpoint the root cause of errors, and understand the overall request journey. So if you talk about the tools that can be used for distributed tracing, so here you have the tools such as Jaeger and Zipkin. The second technique or the second step over here is metrics collection. So basically over here you can collect key performance indicators or KPIs such as response time, error rates, throughput, and resource utilization like CPU and memory for each particular microservice. Over here you can use tools such as Prometheus. So Prometheus is a very open source monitoring and alerting system that collects metrics including various sources such as applications, operating systems, and cloud infrastructure. And the third step is visualization and alerting. So over here, you can visualize collected metrics and tracing data using dashboards and create alerts to notify teams of critical issues. So the popular tools that are used in this particular step is Grafana and Kibana. The next question is, what are DDD principles in microservices? So basically, DDD stands for domain driven design. So this is a software development approach that emphasizes on creating software models that align with the business domain. So when applied to microservices, DDD principles can help structure and organize services effectively. So if you talk about the DDD principles, so the first point over here is the bounded context. So a clearly defined boundary within a specific model and a terminology is applied within microservices. So each microservices should represent a bounded context encapsulating a specific business domain or a subdomain. So this promotes loose coupling and independent development. The second principle is ubiquitous language. So over here you have a shared vocabulary between business experts and developers, and this ensures clear communication and understanding of the domain. So for a microservice application, you have consistent terminology across teams and services, and this prevents ambiguity and improves the collaboration. And the third principle is aggregates. So basically, an aggregate is a cluster of associated objects that are treated as a single unit for data updates. So for a microservices application, aggregates help maintain data consistency within a bounded context. So by applying these DDD principles, you can create a more cohesive and maintainable microservices architecture that aligns with the business domain. The next question is, how do you design for scalability in microservices? Scalability is a very important aspect of designing and operating microservices. So, scalability ensures that your service can handle increasing traffic or data volumes without experiencing performance degradation. So, there are a few strategies that you can implement while designing for scalability in your microservices application. So, the first strategy is horizontal scaling. So basically, the idea over here is by adding more instances of a service to handle the increased load. And now, what is the benefit of horizontal scaling? So here it is very easy to implement horizontal scaling, and this provides a quick and effective way to handle temporary traffic surges. Then the second technique is by using database partitioning or sharding. So basically, distributing the data across multiple databases to improve read and write performance. And now, why do you use this technique? So this reduces the load on individual database, and it also improves the read and write performance for large data sets. The third technique is by using caching. So caching basically means storing frequently accessed data in memory to reduce the load on the underlying database. So caching significantly improves response times for frequently accessed data, and it also reduces the load on the database. The fourth technique is by using load balancing. So load balancing means distributing the incoming traffic across multiple instances of a service. So load balancing prevents the bottlenecks and ensures even resource utilization and service instances. And load balancing also improves the overall system performance and availability. The fifth technique is asynchronous processing. So processing tasks in the background to avoid blocking the main request or response cycle is asynchronous processing. So this improves the responsiveness of the main application, and it also enables handling time consuming tasks without impacting the user experience. And last but not the least, you have the service mesh. So basically, this is a dedicated infrastructure layer that handles communication between microservices. So by implementing these strategies, you can ensure that your microservices architecture can scale effectively to meet the demands of your growing business. The next question is, what is chaos engineering and how is it applied in microservices? So chaos engineering is a discipline that involves intentionally introducing controlled failures into a system to test its resilience and ensure fault tolerance. So it is based on a principle that if you can break your system in a controlled environment, you can identify its weakness and improve its ability to withstand unexpected disruptions. So basically, there are a few principles of chaos engineering. The first one of it is planning for failure. So before introducing chaos, it is crucial to define the scope of the experiment, the types of failures to simulate, and the expected outcomes. So this helps you ensure that chaos experiments are meaningful and they provide valuable insights. The second principle is simulating the real world conditions. So chaos experiments should aim to simulate real world failures as closely as possible. So this includes simulating network latency, server crashes, disk failures, and other common disruptions that can occur in a production environment. And the third principle is learn and improve. So the results of chaos experiments should be carefully analyzed, and through this you can identify the weakness in your system. So this information can then be used to improve the design of the system, implement mitigation strategies, and enhance the overall system resilience. So there are a few tools with the help of which you can implement chaos engineering. Like these tools are Chaos Monkey, Gremlin, and so on. So if you talk about the example over here, so Netflix famously uses Chaos Monkey to randomly terminate instances in its production environment. So, by simulating instance failures, they have identified and addressed numerous weaknesses in their system, ensuring that their streaming service remains highly available and resilient to unexpected disruptions. The next question is, how do you perform logging in a distributed microservices system? So basically, logging is a cornerstone of monitoring, debugging, and troubleshooting in a distributed microservices system. So it provides valuable insights into the behavior of individual service and then particular interactions. So there are a few points that you must consider, or you must implement these points in order to perform logging in a distributed microservices system. So the first point over here is centralized logging. So basically, centralized logging avoids the complexity of managing the logs from multiple services independently. So over here you have centralized solutions that enable efficient aggregation, analysis, and visualizations of logs across the entire system. Then you have the structured logging. So instead of plain text logs, here you use structured formats like JSON or key value pairs. The next step is through the use of trace IDs. So each request should be assigned a unique identifier or a trace ID that propagates across all involved services. So this allows you to trace the journey of a request through the entire system, making it easier to identify and troubleshoot the issues. The fourth technique is by using the log levels. So over here you utilize different log levels like debug, info, warn, error to control the verbosity of the logs. And last but not the least, you have the security. So security ensures that sensitive information like API keys and passwords are properly masked or redacted from the logs. The next question is, what is the purpose of a retry pattern in microservices? So the retry pattern is a crucial strategy for handling the transient failures in a distributed microservices architecture. So transient failures are temporary issues like network glitches or temporary service unavailability or database timeouts that usually resolve themselves within a short period. And now if you talk about the purpose over here, so there are two purposes of a retry pattern in microservices. The first one is it improves the reliability. So by automatically retrying the failed requests, the retry pattern enhances the overall reliability of a system. So it helps ensure that operations can be successfully completed even when temporary disruption occurs. And the second purpose is prevent overloading. So implementing exponential backoff is the key over here. So this increases the delay between the retries with each attempt. And this also prevents of a flood of retry requests from overwhelming the failing service during a temporary outage. The next question is, what are sidecars in microservices? Basically, a sidecar pattern is a design pattern in microservices where a lightweight helper container runs alongside the main application container within the same deployment unit, which is basically a typical Kubernetes pod. So now, what are the responsibilities or the uses of sidecars in microservices? The first use is the monitoring and logging. The second use is network traffic management. The third use is security. And the fourth use is the feature delivery. For example, in a payment service, a sidecar container could encrypt sensitive data, collect and forward logs, and handle network traffic. The next question is, what are the best practices for deploying microservices in a production environment? So deploying microservices effectively in a production environment requires careful planning and a robust approach. And now if you talk about the best practices over here, the first practice is containerization. So basically here you package each microservice into its own container, like by using a Docker. And this provides isolation, portability, and consistency across different environments. After that, the second point in containerization is the orchestration. So here, utilizing container orchestration platform like Kubernetes to manage the deployment, scaling, and networking of containers. The second best practice over here is CI/CD or continuous integration and continuous delivery. So over here, you automate the build, test, and deployment process using the CI/CD pipelines. So this ensures faster and more frequent releases with reduced manual effort. The third principle is deployment strategies. So there are a few deployment strategies that you can follow for microservices architecture, like blue-green deployments, canary releases, A/B testing, and so on. The fourth best practice is monitoring and observability. I repeat. The fourth best practice is monitoring and observability. So over here, you implement centralized logging to collect and analyze logs from all of the microservices. So this helps in troubleshooting issues and identifying the performance bottlenecks. Then you have the service discovery. So this enables services to dynamically discover and locate each other within the network. So this enhances the flexibility and simplifies the service interactions. And last but not the least, you have security. So in security, you have concepts like authentication, authorization, data encryption, regular security audits, and so on. So these are some of the best practices for deploying microservices in a production environment. So guys, with this, we have come to the end of this session on microservices interview questions. I hope you guys have enjoyed this session. If at all you have any doubts or queries related to this session, then you can write them in the comment section and we will try to resolve them as soon as possible. So guys, thank you so much for being with us and I wish you all the very best.